Assalamu alaikum. In the previous lecture, we discussed different measures of dispersion, including range, mean deviation, variance, and standard deviation of population as well as sample. In this lecture, we shall discuss that once we have calculated the standard deviation, how is it useful for us, how it can be used to find out what percentage of observation lie within a specific number of standard deviation. For example, if someone asks you to cross the river whose mean depth is 3 feet, and we know its standard deviation is 1 feet, then we can easily calculate that what percentage of the values will lie between 2 and 4, what percentage will lie between uh, 1 and 5 if the mean is 3. So basically this lecture is in continuation of the previous lecture, and this lecture assumes that you understand the calculation of range, mean deviation, variance, and standard deviation, and you also understand that what is benefit of mean deviation over range, and what is benefit of variance over mean deviation, and what is benefit of standard deviation over variance. So if now when we have calculated the standard deviation, Chebyshev's theorem, Chebyshev was a Russian statistician who said that according to his theorem, for any set of observation, whether it is sample or population, the proportion of values that lie within k standard deviation of the mean is at least 1 minus 1 over k square, where k is any constant greater than 1. For example, the arithmetic mean bi-weekly amount contributed by Dupree Paint implies to the company's profit sharing plan is $51.54. So if the mean is $51.54 and the standard deviation is 7.51, at least what percent of the contribution lie within plus 3.5 standard deviation and minus 3.5 standard deviation. So we shall put this 3.5 standard deviation in this formula 1 minus 1 over k square, where k is number of standard deviation, and we want to know the proportion of or percentage of the observation lying within 3.5 standard deviation. Square of the 3.5 is 12.25, so 1 over 12.25, when it is subtracted from 1, the answer is 0.92. So we shall conclude that 92% of the values lie within 3.5 standard deviations if the mean is 7.5, sorry, 51.54, and the standard deviation is 7.51. We can easily calculate the boundary numbers as well. One thing that this theorem is applicable to any type of distribution. It does not assume, or it does not state that there should be normal distribution or any other specific distribution. However, if we want to be more accurate and distribution is normal distribution, then we can become more accurate. First of all, normal distribution is a bell-shaped. This is also known as symmetrical distribution, as you can see in this graph. And 50% of the observation lie below the mean or to the left side of the mean, while 50% of the observation lie towards the right side or above the mean. So if the distribution is normal, then according to the empirical rule, 68% of the values or observation will lie within one standard deviation. 95% of the values will lie within two standard deviation, and 99.7% of the values will lie within the three standard deviation. Here, if mean is 100 and standard deviation is 10, one standard deviation mean 100 minus 10, 90, 100 plus 10, 110. So between 90 and 110, 68% of the all observation will lie between 90 and 110. And if when we subtract 2 standard deviation from 100, so 2 into 10, 20, 20 minus 180, and 20 plus 100, 120. So between 80 and 120 are within 2 standard deviation. 95% of the values will lie. Similarly, 99.7%, almost you can say all the observations will lie within the 3 standard deviation if that distribution is the normal distribution. Now we shall discuss the arithmetic mean of group data. We already know that if we have to find out the arithmetic mean, we will simply add the values sum of x over n. However, if this is group data is like frequency distribution, which I'll show you in the next slide. Then we will multiply the frequency with the m, where m is the midpoint. Then we'll take its sum and divide it by the n, and we will get the x bar, which is the arithmetic mean of group data. We can easily understand this formula or group data and its mean calculation in the following example. So group data is a data which has the distribution like this, which has a class like this. So this is a data of cars selling prices. So the selling price of car is $15,000 to $18,000, and so total 8 cars were sold in this range. In a price range of 18,000 up to $21,000, 23 cars were sold, and so continue in the last range from 33 to 36,000, 2 cars were sold. So total, this is a data of 80 cars, out of which 8 were sold in this range, 23 were sold in next range, and so on. So this type of data is known as grouped data. And group data and its mean calculation is a little bit different from a simple mean. Now, these are the same ranges. In this slide, we will see how the mean is calculated. These are the simple ranges, and here is the frequency. The third column is M, midpoint, and how it is calculated. Uh, from 15 to 18, there are 16, then 17. So 16.5 is midpoint of 15 and 18. In other words, or in other way, you can simply do it: 15 plus 18 divided by 2, you will get 16.5. So 16.5 is at exactly middle of the 15 and 18. So this will be midpoint. Similarly, 19.5 is exactly at the mid of 18 and 21. So we can call it 19.5 is the midpoint. In this way, we shall calculate the midpoints of all these price ranges. Then in the next step, we shall multiply this midpoint with the frequency. So 16.5 multiplied with 8 will be equal to 132. Then 19.5 is m, its frequency is 23. So 23 multiplied by 19.5 is equal to 448.5, and so on. At the end, we add them up, and this becomes equal to sum of fm. And then as formula shows that we have to divide it by the n. N is here sum of the frequency or total number of the cars, which is 80. So we will divide it by the 80. So the mean or average price of this car sold is $23,100. This is how do we do the calculation for the mean of group data. Once we find out this mean of the group data, then we can use this mean of the group data in the calculation of variance and standard deviation. And this is a formula of standard deviation of a sample. We denote it by the S. What we do, we subtract the mean, which we just calculated in the last slide, from each midpoint. We take its square, and then we multiply it with the frequency, and then we add them up. And as this is a sample standard deviation, therefore we are dividing it by n minus 1 instead of dividing it by n as we do in case of a population standard deviation. Okay, now let's move to its calculation. This is the same data. We had calculated the midpoint. We had calculated the mean in the last slide. So now we shall subtract that mean from each value of these midpoints. So 16.5 minus the mean which we calculated in the last slide. I can show you again here. Our mean was 23.1. So 16.5 minus 23.1, 19.5 minus 23.1. So we shall subtract the mean of group data from the midpoint. Then we shall take the square of this column, and then we shall multiply it with the frequency. Here in the second column we have the frequency. So 8 multiplied by 43.56 is equal to 348.48. 23 multiplied by 12.96 is equal to 298. In this way, we calculate this entire column, and then in the end, we add these values. So this value is used here. So this is sum of frequency multiplied by deviation of midpoint from the mean. Sum f multiplied by m minus x square. We divide it by n minus 1. Total cost was 80. So we are calculating for sample. So we will do 80 minus 1, 79, and our standard deviation answer will be 4.403. Use of standard deviation in addition to the above mentioned uses. Standard deviation is widely used as a measure of risk in finance and in other business related fields. In finance, risk is a deviation from the expected value. We use the mean value as our expected value. That in the next, for example, if we invest in a stock market and over the previous year we earned a 20% return from that stock investment, we expect that this mean of previous year will continue next year. So this mean is used as the expected value. So any deviation from the expected value is considered to be a risk. And standard deviation is basically the same thing, deviation of values from its mean. So higher the deviation, higher the standard deviation will be, higher will be the risk, and vice versa. However, a very technical point is here that this deviation or unexpected return is in either direction, whether it is above the mean or it is below the mean, it is used in the calculation of standard deviation. However, if you think that if your expected return is 20% and risk is only getting return lower than 20%, then we shall not use the standard deviation. Then we shall use the semi-variance, which only takes the lower values. So if we want to measure only downside risk, then we shall use the semi-variance. Thank you very much. Assalamu alaikum.